Okay, there's probably at least one center of mass problem on the test. So give me thumbs up if that center of mass problem is really obvious for you. Being calculus students. Okay, it's the way mostly obvious. It's the weighted average. So I multiply the position times the mass for every single thing and divide by the total mass. It's the definition of a weighted average. Okay. Last few. Oh no. If there was no external force, no net external force, they're even that specific. Good job, Princeton Review. Acting on the objects, but some kinetic energy is lost. Then, okay, no external net force. You're just supposed to read that as momentum conserved. Because if there's a net force, momentum was transferred out of the system over time. If there's a net external force, that's what it does. Forces change momentum over change in time. That's really how Isaac Newton thought of it. And you're learning Newtonian mechanics. If there's no net external force, momentum's conserved within the system because you're going to only have action-reaction pairs transferring momentum between the parts of the system. Okay. But some kinetic energy was lost. Some kinetic energy lost means inelastic. That's what inelastic means. Plain old elastic means kinetic energy conserved. So everywhere it says elastic, oh no, it's not that one. Elastic, no, it's not that one, because it says in code words here, kinetic energy lost, inelastic. Was not elastic, aha, and linear momentum was conserved. So I think it's C, but I better read all the choices because I'm looking for the very best one. Not elastic, and momentum's not conserved. Oh, well, that's like not even in our universe. But they could have said there was external forces. So, and then E, none of these. Now I found one that was pretty good. So I'm going to go with C. Okay. 3 thin uniform rods. It's L over 4. Why? Sure did.
For each rod, you can think of it in terms of its own center of mass. So like you can combine the two lengthwise ones into you can basically think of it in terms of a T. And
Absolutely.
think of the center of mass of like the vertical portion of the T is going to be at L over 2. And then you basically just do a torque problem with your two center of masses. So
Doesn't even need to be torqued. This is the triangle masses homework problem that I gave you with different axes. I have 3 masses. They're arranged in a triangle. Sure. Where is the center of mass on this central axis? So put a y-axis through the middle. What is the y-coordinate of the center of mass of this system? If that's my y-axis, and I guess, and they want how far below. So they want to say this is y equals 0, right there across. Okay. I have a logic way to do this easier. If you compute that, you'll get L over 4, or y equals, the center of mass will be y equals minus L over 4 if you did a y-axis like that. But okay, here is 2m worth of mass down here, and its center of mass is going to be right there. Right? There's 2 equal legs equally spaced, so the center of mass is actually in the middle. Okay, and it's 2m worth of mass. Oh, I got you, Shannon. And then I have a 2m here and a 2m here. So the center of mass of this 2m and this 2m is in the middle, and it's a total of 4m. So it's got to be in the middle. And if the legs are each 1L long, then the span from here to here is L over 2. So you divide it by 2 again and get L over 4. So you can kind of eyeball it. Maybe you don't need to calculate. Oh, man. There will be some tricks. Like I'll give it away. On the first page of the test, there's some problems about vectors, and they're drawn on a grid, and they got nice angles and everything, and you might think you have to calculate those vectors, like because they're lined up with the boxes, and you can really calculate their magnitudes and components, all that stuff. Not really. If you just think, okay, they're lined up so you can easily compare them on the boxes. If you just compare, like they all cancel out except one, that's the whole question. All right, so we're trying to maybe get plenty of sleep. I got extra sleep somehow over the weekend. I can't really accomplish more, but I can think more clearly, and I can communicate better. I can tell. Okay. Anybody still need those? The last 2. Bless you. Yeah, if my cough is better, it's because I took allergy medicine. Okay. Oh dear. This one, so perfectly inelastic, Shannon's code word, they stick together. So you can be plain old inelastic, and that just means you lost some kinetic energy, but maybe there was a bounce and stuff. Plain old inelastic means they have to have given you enough momentum information to solve the whole problem. But perfectly inelastic means they literally stuck V1 final equals V2 final. So you do momentum conservation, and you get your V final for both is going to be like -7. If this is plus, so if your car is going in the plus direction, just because I read that one first, and then your truck is -21. Oh, here. Let's just make it a magnitude and not worry about it. Okay. They're going in opposite directions. The truck has twice the momentum because it has twice the mass. So then they skid to a halt, okay? You can assume that you knew this 21 meters per second at the instant of the collision. So you just do momentum to get that 7, and then you skid to a halt. Well, so the work done by friction is minus the change in kinetic energy. Oh, and actually, no, it is the change in kinetic energy. Okay, so that's the total mass, kilograms, uh, divided by 2 times V final squared with a negative sign because you came to a stop. So you compute that. So what I did actually, as I said, okay, I have 1500, and then I have 49 is about 50. Yeah. So how much is it? It's 1.5. Oh dear. I gotta change it. I think it's 73. Because it's just 1.5, not 2.5. I better calculate. Pretty sure I circled D on my answer key. Oh yeah. Okay. It should be B. Alright, and then which describes a perfectly inelastic. They're just quizzing things again. Okay, but free of external forces. So momentum is conserved. Not never. Momentum is conserved. Not sometimes. Definitely. Okay. I would cross those sometimes ones off. Just like that. So 9 is B and 10 is C. And even I got one wrong. Because I thought 1.5. Okay, I got 49 and 1.5. I somehow made 150 in my head. Maybe you get a bonus. So number 9 should be B, not D. Okay. Any questions? Okay.